Welcome to saitechinfo channel, my dear student. In today's lecture, I'll be discussing about NBS, that is N-Bromo Succinimide. Before that, let us try to understand the structure of N-Bromo Succinimide. You know the carboxylic acid, which is nothing but RCOOH. The best example is acetic acid, which is nothing but ethanoic acid, CH3COOH. We have got dicarboxylic acids also. The simplest dicarboxylic acid is oxalic acid, COOH bond COOH. And the succinic acid is also a dicarboxylic acid. It is given in this diagram or the reaction. You just look at this CH2COOH and the CH2COOH. So, since it has a 2-carboxylic acid, it's a dicarboxylic acid, succinic acid. On reacting with ammonia, any acid gives amide. So, in this case, dicarboxylic acid combines with amine to give imide, so succinimide. On further bromination, you are able to get N-Bromo Succinimide. That indicates bromine is attached to nitrogen. So, N-Bromo Succinimide is a very good reagent in organic reactions. There are some salient features of N-Bromo Succinimide. It provides a low concentration of Br2. But you may ask me, sir, why don't we use bromine itself directly for bromination? In fact, handling bromine liquid is not at all comfortable in the laboratory. It produces dense orange fumes and it is pungent and it is something obnoxious and we cannot tolerate this. Whereas this NBS is a white crystalline solid, it's very easy to work with that. So, the bromine is attached to N in NBS and that has a partial positive charge. Therefore, it is electrophilic. So, it's useful as a reagent in organic reactions. There are two applications here. This NBS can be used in allylic or benzylic bromination. It's also used for the formation of bromohydrin from alkenes. Now let us see what is allyl and benzyl group. So, you know something about the vinyl group, that is vinyl is nothing but CH2 double bond CH. Whereas allyl is, that is CH2 double bond CH again CH2, that is called allyl group. Allyl chloride means CH2 double bond CH single bond CH2 Cl. So, it makes the difference. Similarly, we know benzene C6H6, but C6H5 is phenyl, it should not be called benzyl. But what is benzyl? C6H5, CH2 is called benzyl group. So, this is the benzene structure and you can find this as the benzylic attachment. So, similarly here, this is the allyl attachment, that is the bromine is going to be added in the allyl functional. So, it's called allylic bromination. In the case of benzene, it is a benzylic bromination. So, with this background, we will try to explain the reaction. So, the NBS in allylic bromination, and that can be represented as, that is CH2, CH2, C double bond O, C double bond O, then N, it is linked by N, and bromo, so bromo. As I already mentioned, this bromine has the positive charge, so it can be acting as an electrophilic reagent. Here, let us consider any alkene. Let us consider in this case cyclopentene. So this cyclopentene can be brominated using this NBS in presence, by heating in sunlight, that is photons, so that we are able to get the allylic bromination. Are you able to understand this? So that is the bromine is attached to what? That is a double bond, and next to that there is a carbon atom. So it is attached in the carbon atom next to the double bond. And the byproducts are hydrogen bromide, then succinimide. Do you understand? So this is known as allylic bromination. Okay? Right. Now let us see what is benzylic bromination. In the case of benzylic bromination, you can see, let us consider toluene C6H5CH3. So let it be subjected to the reaction with the NBS in presence of photons or by heating. Now we are able to get the benzylic bromination, that is, the bromine is attached to the side chain carbon atom. Okay, do you understand this? And that is why it is benzylic bromination with the formation of HBr and succinimide. And the NBS is also used in the formation of bromohydrin. That is, when hydroxyl group and bromine or any halogen atom attached nearby the or the next to the hydroxyl group, they are called halohydrin. In this case, bromohydrin. So we can take a cyclohexene, an alkene, when it is subjected to reaction with the NBS in presence of water, we are able to get bromohydrin with the formation of succinimide as a byproduct. Okay, I hope this video should have been very useful to you, especially for the medical and engineering aspirants. Thanks for watching this video. Please subscribe to Saitech channel and get the latest videos. You can also send your doubts in the comments column. Okay.